House Bill 3402. The legislature passed this in July of last year. What it did was to raise the speeds on 1,200 miles of rural highway and 300 miles of interstate in eastern Oregon. It took most of that 1,200 miles of rural highway and took it from 55 miles an hour to 65 miles an hour for cars and to 60 miles an hour for trucks. The interstate from the Dalles to Ontario goes from 65 to 70 for passenger vehicles and to 60 miles an hour for trucks. There were a lot of implications. You raise the speed limit, what else is affected? Signs, transition areas where you might be coming to a new speed limit in a city, and striping. In particular, pass and no pass zones. How do we make sure that those are safe at the new higher speeds all across the system? And the traditional way of doing that was for somebody to go stand in the middle of the road and another person go down the distance that particular speed said you should be that far away if you're going to start a passing maneuver. And they would talk back and forth and say, well, can you see me now? And we thought that for 1,200 miles of rural two-lane highways, that was a daunting task. Couldn't there be another way, a safer way, and a more efficient way of trying to evaluate where we needed to be? And we spent a little bit of time trying to figure out if any other state had gone through this in such a large change on a two-lane rural highway. And what we got back was that most of the upper speed limits that had happened were on larger facilities like interstates. And this kind of striping issue hadn't had to be considered over the course of hundreds of miles of highway. So we thought about a lot of things, and one of the things that came up was that the Department of Transportation had a vehicle that allowed us to collect information about our highway in a pretty amazing way.
Our mobile mapper is mounted on top of a vehicle, and it contains 7 cameras that take a panoramic image. It also has a laser scanner that collects about 1 million points per second, and the images are collected at about every 25 feet.
We determined that the data set that we have, which is essentially LiDAR that we collected across all the state highway systems with our mobile mapping device, was something we could use to determine the sight distance requirements for the no passing zones. LiDAR is light detection and ranging, and it is a tool that is used to calculate or to capture 3D positions of anything you want. And so it is essentially a system that puts out a laser pulse that goes off in a particular direction, hits something like a tree, comes back, and we can calculate the distance. Then based on calculating the angles and distance, we can get a 3D point in space, and then we do that millions of times a second, and we end up with what you might think of as a hologram, one way to think of it, or as a 3D photograph. A photograph that you can actually step into, look around, up, down, left, right, measure, and do whatever you want. It's very accurate, within a quarter of an inch or so. We sat down and discussed whether it was possible. We discussed who would do what, and we came up with this collaborative effort. Geometronics taking the existing data that we had and mining it for the information that was needed so that the roadway team could then calculate the sight distances, who would then pass it on to the traffic team, who would develop a set of plans so that they would then pass that on to the striping crew who would stripe the roads.
After Geometronics gets the data, we take it and process it, and then we trace the features of the roadway and create a map, and then that is used to create a model of the roadway.
What Roadway's part was, after we collected the data from the Geometronics unit, we created a three-dimensional model of the roadway, representative of the roadway location, and then included a vertical element at the edge of the pavement that then we used our design software package to analyze the sight distances, where the sight distance was acceptable or not acceptable, and then gave that off to traffic.
It required a lot of collaboration across many different disciplines, across a lot of different offices and geographic locations. We had regions and districts across regions 4 and 5, and the respective striping crews and traffic crews out there as well. Everybody had their own little piece of the pie, and every piece was extremely critical, but the end goal was to get a plan to the striping crew as quickly as possible in a way that they could easily pick up and lay out and install before the end of the season.
So out of all of that, we were able to get all of the striping in place well in advance of the close of the weather season, and signs will all be going up within the first week of when the new speed limits are operational, which is the week of March 1st.
LiDAR is an amazing technology. It enables the creation of a virtual world which can be used for a multitude of things, and your imagination is really the only limiting factor. We can use it to extract all sorts of data and information from it. We can use it to overlay things on it, and in essence, we're creating the world at your fingertips. This effort actually showed the value of collecting LiDAR data across the entire state highway system, and without it, we would have struggled to accomplish this task.